So after creating a serial deletion of your endotoxins, okay, so here you should have 0.5 EU per mil, 0.25 EU per mil, 0.125 EU per mil, 0.0625, and if you have the 6 tube, that'll be 0.03125 EU per mil. So you created a serial deletion of endotoxin there, right? And the tube 1 is there's no endotoxin, there's 0 endotoxin there. Okay, so that's what you have done there. Okay, and to that, now you're going to give it another vial which contains the LAL solution, so limitless amyloid solution. Okay, that is fresh made. Okay, so about 0.1 ml solution of that will be added to all the tubes. Okay, all the serial deletion tubes, as well as the tube that has just endotoxin free water as well. So all these tubes will be given with the LAL solution. So then what do you expect to see? Of course, the first tube that didn't have an endotoxin, nothing will happen, right? It will stay as liquid continuously. But in these tubes where some endotoxin is there, so LAL will start forming the coagulation, okay, starting from tube number 2 all the way to tube number 6. Depends on how much of endotoxin is present there. So since tube number 2 is the tube with the highest concentration of endotoxin, of course it will give you enough coagulation, I assume. Okay, and maybe this one as well. Maybe we'll see a detectable amount of coagulation happening among these tubes, but I don't know where it's going to end. So that will determine the sensitivity of your assay, which means, how much of the minimum endotoxin your LAL can bind and then form a coagulation. So the whole purpose of setting up these tubes is to determine that assay sensitivity. Okay, does that make sense? Okay, and then after that, so the assay sensitivity will be determined from those first set of the tubes. Okay, so let's say you did that, you set it up, and you're going to incubate your tubes in the 37 degree about 1 hour, and you found that result. Okay, what is the result? So of course from the first tube there is no endotoxin, there is no gel formation, right? And then from these tubes where the serial deletion of endotoxin was made, you saw the gel formation from the first, second, and third. And the fourth and the fifth did not give gel formation, it was still liquid. Then what does that mean? So what it means is your LAL solution you added was able to form the coagulation up to these 32 tubes, which had the minimum concentration of 0.125 EU per mil, right? So that's the amount of endotoxin your LAL solution can detect and form coagulation. So that is detectable. However, if the endotoxin quantity is less than that, maybe 0.065, then the coagulation doesn't happen because LAL is not sensitive enough. So if you have this data, that means your assay sensitivity, which means the smallest amount of endotoxin you can detect with your LAL solution, is up to here 0.125 EU endotoxin unit per mil. That's what you can get out of the first set of the experimental setup. Does it make sense? Okay. After that, okay, actually you're going to set this up at the same time, but there's a second set of test tubes. Okay, the similar way you will have total 6 test tubes that are endotoxin free set up on a test tube rack. Okay, maybe you can share the same rack. On that rack you're going to have all these endotoxin free tubes, and it's the same setup. You're going to add endotoxin free water 0.1 ml to all those tubes, and the first tube will not be added with anything else. It's just endotoxin free water, right? But the rest of the tube, these 5 tubes, will be mixed up with something. Okay? Besides the endotoxin free water, you will be adding something. What are you going to add? The testing water solution. Okay, depends on what water you're going to test. Maybe the tap water or DI water, or maybe another dirty water, whatever you have, even your speed if you want to, you can test it. Okay, to the first tube, maybe tube number 2, add the same volume, 0.1 ml of the testing water sample. Okay, and the same way mix up and then transfer 0.1 ml to the next tube. Okay, after changing the pipette tip, of course, and then pipe it up and down, mix up, and then change the pipette tip and transfer to the next tube. Okay, and then pipe it up and down, mix it, and then change the pipette tip, transfer. Okay, and then pipe it up and down, mix them together, and change the pipette tip and transfer. Okay, and then pipe it up and down, and then from this tube you're going to discard 0.1 mil. Same serial dilution. Okay, now the only difference is what? Instead of adding endotoxin there, you're adding the testing water here. Okay, you're creating a serial dilution of testing water there, right? So here you have maybe half full the dilution of your testing water sample in this tube, and the first tube, of course, there's no testing water sample added there. Okay, but this tube had half dilution of the testing water, and this tube will have 1/4, maybe 1/4 dilution of the testing water sample. Next one will have 1/8. Next one will have 1/16, and the last one will have 1/32 dilution of your testing water sample there, right? After that's done, you're going to add 0.1 mil of your LAL solution to all these tubes, and then set those tubes in our incubator together with the first set. Okay, then what are you going to expect to see from here? It all depends, how much of endotoxin is present in these tubes. Some of them may give you gel form, some of them may not. It totally depends on the amount of endotoxin present here. Okay, so let's say you got this result from your second set of the tubes. Okay, so the result says for first tube, of course, there's no sample added, so there's no gel formation, right? But from these tubes, you got maybe gel form, but the last one did not give the gel form. Okay, now what does that mean? What it means is you had enough endotoxin present in these tubes, but this tube, the last one, didn't have enough endotoxin to give you coagulation, right? So up to here, these 4 tubes had enough endotoxin. How much of endotoxin? Maybe if you look at the pattern, this tube had maybe endotoxin similar to your previous tube. Okay, maybe this one, which had 0.125 endotoxin unit per mil concentration. All right, the trend is same, so you can expect maybe this tube had the same amount, 0.125 EU per mil of endotoxin concentration. Okay, if that's the amount of endotoxin that this tube had, so 0.125 EU per mil, well, that's fine. Then how much of endotoxin is there? Okay, maybe double amount of 0.125. Okay, so maybe it's 0.6 EU per mil. How about here? Maybe twice as that, maybe 0.125. How about here? Maybe what is the 0.25 here? Okay, and how about undiluted sample? Maybe it's twice that, maybe 0.5 endotoxin per mil. Okay, so if you trace back, okay, by maybe multiplying the dilution factor, which is 1/16 here, okay, to the assay sensitivity, because this the coagulation is the same pattern as the previous set here, okay, which you saw here. Okay, so it's 0.125 giving the last gel form, right? So that means this tube may have the last gel form. So you can assume that this may have the same concentration as 0.125 EU per mil. So 0.125 EU per mil. And then what was the dilution factor here? So it was diluted like 1/16. That means if it was not diluted straight sample water, there should be about 16 times more endotoxin there. So that's why you have to multiply 16 to estimate the amount of endotoxin present in the undiluted sample water. Okay, so if you do the math, 16 times 0.125, you can see that it's about 2. Right, so that's 2 EU endotoxin unit per mil. So that's how this assay works. Okay, so hopefully you can set up 2 sets of tester tubes with your partner and then test the sample water. It could be whatever the water you want to test. Maybe dirty sink water or nano pure water in the lab or tap water. You can determine the amount of endotoxin there. Maybe if you want to test your spit, you're welcome to if you like. All right. Okay, so that's the first assay, endotoxin quantification using LAL assay. Okay, and then next part of the lab, we're going to deal with the environmental monitoring. Again, some of you have done this lab in the previous class. If that's the case, you can help your partner, all right, who haven't done it. So, so environmental monitoring, when you say, that means it's a kind of assays that are taking place in your manufacturing process or manufacturing space. So the manufacturing environment should be very clean. How do you make sure it's clean? You have to do the testing all the time. So the testing activity is actually environmental monitoring. Okay, so by doing environmental monitoring, you can evaluate the cleanness of your maybe space or process or personnel actually who are working in there. Okay, so you are capturing the samples and then testing, quantify the amount of maybe contaminants in that sample. That's what you do. That's the environmental monitoring. So it's a snapshot because you are taking some samples and quantifying amount of contaminants existing in the sample, right? So that's what you're doing. So by taking the snapshot, you can evaluate the cleanness of your manufacturing environment, and then if needed, you can take whatever the actions you need to take if there's too much of contaminants. All right. So it is the establishment of a compliant environmental program is extremely critical in aseptic processing, because aseptic processing requires very clean condition, clean space, clean environments, clean process, clean personnel. So you need to be able to demonstrate that by doing this. Okay. So what kind of things should be measured? You will be measuring non-viable things in your sample. If you are taking an air sample, for example, in your clean room, you need to measure how many particles are floating in your air sample, okay, by using a special device called particle counter. Okay, so facility control system, for example, HPSC, HEPA filter, their quality will be demonstrated by measuring the amount of particles present in your clean air. And then you can also measure the viable particle. Viable means what? Living particle. Okay, in your air, there are a lot of things floating in there. Some of them may be living. Okay, maybe some bacterial cells and their spores may be floating. Then how do you know if those particles are living or not living? By using different measuring testing method. Okay, so for example, if you taking an air sample, there's another instrument called air sampler that can measure the amount of living particle in your air sample. You can also use different petri dishes to make contact plates to see how clean the work surface is. Okay, if it is a personnel who is gowned up aseptically, you can see if that gowned up PPE is really clean by taking some contact samples from the gowned individuals. Okay, if you're looking at the water sample, of course, and not only you can do the LSA, you can also measure the amount of viable things in your water. Okay, so there are many different ways of measuring this. Okay, viable sampling method that can be measured in quantity. Okay, let's see. So these are the instruments that you can use. This is called something called the air sampler. You can draw in a set volume of air through these holes, and this petri dish medium will be placed under this metal cap, and whatever the air goes in will make touch on this petri dish medium. Okay, after the air is blown in, taken in, you can take the plate out and incubate and see how many living things can be found after 2 days of incubation. It can come as this shape or that shape. Those are called air samplers that can measure you the viable particles in your air sample. And you can also use these petri dishes and set them up and then leave the lid open and see how many things are settling on top of your plate. We call them settle plates. Okay, after a certain hour, maybe 1 hour, you come back and put the lid back on and incubate and see. So that'll measure the amount of things floating in your air. And these things are called particle counters. They can measure particles in your air, regardless of living or non-living. So the set volume of air will be drawn in through these holes, maybe holes, and there will be a laser beam shining through the air, and it's going to quantify the things floating in the air sample. It's a particle counter. Okay, so you can use these devices. And then this is called a Rhoda plate or contact plate. Okay, the design of the petri dish is unique, so you can, if you put the lid off, take it up, and the petri dish is right there, so you can make a good contact with the surface of maybe individual, gowned up individual, or surface of the cleaned work area. Okay, so by taking the contact sample, you can measure the amount of living things in your sample.